Hello, in this video, we're going to discuss the areas of polygons. You will learn how to find the areas of rhombuses and kites, find angle measures in regular polygons, and then how to find the area of regular polygons. First, let's talk about the areas of rhombuses and kites. You'll notice in this first image, we have four congruent sides, so that makes this a rhombus. Okay, this is shaded red so that we can talk about this rhombus in terms of two congruent triangles. So the top triangle right here is congruent to this bottom triangle down here. And if I split them apart and flip that bottom triangle, turn it around like this, now you'll see that we have what's called a parallelogram. Okay, a formula for the area of a parallelogram is simply base times height. Okay, well, if we talk about this in terms of the rhombus, the base of rhombus or the base of the parallelogram is the same as the length of diagonal 1 of rhombus, right? So that would make this area equals diagonal 1 times, and then the height of this parallelogram right here is the same as just 1/2 of the height of the original rhombus, or 1/2 of the other diagonal of the original rhombus. So that makes this 1/2 times diagonal 2. And this is how we derive the formula for the area of a rhombus, or it also works for a kite. You just do area equals 1/2 of diagonal 1 times diagonal 2. Okay, so in order to apply that, we have a couple of problems down here. We have in this first figure, we have four congruent sides, so this is a rhombus. We have a diagonal of 8 meters and another diagonal of 6 meters. So we can do the area is 1/2 of diagonal 1 times diagonal 2, which becomes 1/2 of 8 meters times 6 meters. Half of 8 is 4, and then 4 times 6 is going to be 24. So that makes the area of this rhombus equal to 24 square meters. Okay. Likewise, we can use the same formula on this kite over here. You'll notice you have two consecutive congruent sides right here. You have two consecutive congruent sides right here, so that this makes this a kite. And again, the area of a kite, you can find that by doing 1/2 diagonal 1 times diagonal 2. And in this case, diagonal 1 is going to be 10 centimeters, so 10. And diagonal 2 is going to be 7 centimeters. When you multiply 1/2 times 10, you get 5, and then 5 times 7 is 35. So the area of this kite is simply 35 square centimeters. Okay, now let's move on to regular polygons. Okay, some vocabulary that you need to know in a regular polygon are words like the center of a regular polygon. That would be in the very middle of it, like the center of a circle that is circumscribed around the polygon to hit every single vertex exactly, right? That would be the center of your polygon. And then you have a radius of a polygon. The radius is going to be from the center out to a vertex. Kind of like the radius of the circle, it would, go out to your circle. This radius of the polygon is going to go from the center out to a vertex. Okay? And then we have this new term here called an apothem. If you go from the center perpendicular to one of the sides of your polygon, right? So it forms the right angle. That is going to be what we call an apothem. Okay, and that term apothem is going to be very, very useful. We're going to use the apothem quite a bit when we're talking about area. Right? And then lastly, we have this term central angle. The central angle is what you get if you measure the angle from one radius to the next radius. And the way that you find measure of that central angle is that you simply divide 360 degrees like you would have in a full circle all the way around by the number of sides of your polygon. N equals the number of sides. Okay. So let's practice finding angles in our polygon. We have our first problem right here. We want to find the measure of angle AFB. So A starts here. If we go AFB, that's this angle right here. And in order to find that, I'm going to do 360 divided by, let's count the sides, 1, 2, 3, 4, 5. So 360 divided by 5, this is going to be a 72-degree angle. Okay. Our next one here, if we want to find the measure of angle AFG, so AFG is going to be this angle right here. Okay. And that's simply going to be half of the central angle that you found. So half of 72 degrees is going to be equal to 36 degrees. And then finally, we want to find the measure of angle GAF. So if we go GAF, G is here, A, and then F. So that's going to be this angle right here. Okay, that is going to be the other acute angle in a right triangle. Now, the the two acute angles of a right triangle add up to 90 degrees. So that 90 plus your right angle equals your total of 180 degrees in the triangle. So to find the measure of angle GAF, you can just do 90 degrees minus this last angle that we found, 36 degrees. You'll find that this GAF has a measure of 54 degrees. Okay, now let's move on and answer this question. How can you find the area of a regular polygon? Okay, you'll notice here that I have traced out all of the radii in this pentagon. It has 5 sides, so we call it a pentagon. Traced them all out in red, and then I've traced every apothem in green. And the perimeter, I went around the perimeter and highlighted that in purple. Okay, and then I cut apart this pentagon and formed 1, 2, 3, 4, 5 congruent isosceles triangles. Okay, they're isosceles triangles because this radius is congruent to this radius, right? So those two sides are congruent. And then this purple down here, base of the triangle, was one side of the perimeter around my polygon. Okay, in order to find the area of one triangle, you'll recall we just need to do 1/2 times base times height. Okay, in order to find the area of all 5 triangles added together, you would do 5 times 1/2 times the base times the height of an individual triangle. Okay, but let's analyze that a little bit more clearly. Okay, the base of one triangle right here is one part of your perimeter. So if I do 5 times base, 1, 2, 3, 4, and 5, that takes me all the way around the pentagon so that I have the full perimeter. So 5b, that's just going to be perimeter of the pentagon, of the polygon. And then if I analyze the height right here, this is the height of my triangle. If I come back over here and compare that to my polygon, that's actually the apothem, right? So this height right here is the apothem of the original pentagon, right? So that height is going to be times the apothem. And I still have this 1/2 right here that I need to account for. So 1/2, and that's going to be the area of the full entire polygon is going to be 1/2 times the length of the apothem times the perimeter all the way around. Okay. If I want to shorten that formula to have something cleaner to write, I would write the area equals 1/2 the apothem times perimeter. I use